Okay, this is the AM. This is the AM answers, and here are the matching answers. So you can stop this video if you want to see those answers. Um, we're going to focus on AM 21 through 25, starting with the true airspeed in feet per second of the aircraft sea level at touchdown. And that's the simple formula that's been on my board. Um, if you know that the dynamic pressure is 10 pounds per square foot, and you know sea level density 0.00238, then you can solve for the equivalent velocity, and that turns out to be 92 feet per second at touchdown. Now you have a cambered wing, and the next problem asks you if the aircraft is at the stall level angle of attack, and the stall angle of attack for a cambered wing is shown right here, approximately 15 degrees for the stall at the cambered wing, and then you just come over and read C sub L at approximately 1.5. So with that data of C sub L and the angle of attack, then given that C sub L equals 1.5 and dynamic pressure is 10, you have a very simple formula, just of 10 times 1.5 gives you your wing loading, or 15. Wing loading is going to be equal to 15. The next problem, 24, is if the max G's are 4, what happens to maneuver speed? So if your maximum G's are 4, you're still at your C sub L max is still going to be the same. It's always your C sub L max is always going to be 1.5 at stall, because you're always going to be at the tip of that curve, but you'll be there at different velocities. So if NZ is equal to 4 at CLX 1.5, what is the maneuvering speed? So 4 G's over here, that's going to add a 4 to the numerator of the equation, and you have to keep the CL max the same. So somehow 4 is going to have to be added to the denominator. And since sea level density is a constant, the 4 is going to have to come from V squared. So if you put twice the velocity stall at 1 G, 2v in here, then the 2, when you square it, will give you a 4 in the denominator. And that's kind of the secret for working this problem. So if you put twice the stall speed for 1g, twice the stall speed in the denominator, that 2 will come out as a 4 and cancel the 4 for g, 4g's in the numerator, and that will leave maximum CL max, and your velocity will be twice the stall speed at 1g, or twice 92 feet per second, or 184 feet per second will be your maneuvering speed. Or if the maximum G's is 4 for this airplane, that would be your maneuvering speed. And the final question is, what is the max wing loading at 4 G's? Well, again, it's the same thing. Our C sub L is going to stay at 1.5. We have 4 G's in here. We know from the first problem at landing that the weight over wing area, our wing loading at 1G is 15, so at 4G's it's going to be 60. 4 times 15 is 60 pounds per square feet. Now, if C sub L is going to stay at 1.5, that 4 has to also appear in the denominator, right? So your Q has to increase by a factor of 4. So it was 10 PSF at 1G, it'll be 40 pounds per square foot at 4G's to make this equation hold at maneuvering speed. So twice the stall speed will give you maneuvering speed when you can pull 4 G's right at the stall. If you try to pull any more than that, the aircraft will stall. If you go faster than twice the speed, then you'll be able to pull more than 4 G's, but you could pull the wings off the airplane. And the maneuvering speed then is 184. And that's it. Good luck.